What I have here is a Rosemont 3144P dual sensor temperature transmitter. So this right here is the terminals behind the transmitter. So you have a test terminal, positive terminal, negative terminal. Then in the back you got T1, 2, 3, 4, and 5, which are the terminal points for your sensors. And this right here is the wiring diagram for the sensors themselves. So before testing the transmitter, we got to give it 24 volts since it's a 24 volt device. And so this green wire is my negative wire. And then the actual resistor itself is the positive. Next is the 789 multimeter. So we're using the meter to test the milliamps. So once again, the positive will now go on the brown wire, which is the test terminal, and the negative wire will also join the negative wire with the power supply. This is what you call a parallel circuit. So the next device we're going to be talking about is the Trex communicator. So the first thing you want to make sure is that the protocol matches the transmitter. So there's a HART transmitter, so it also requires a HART protocol on the communicator. So now I'm hooking up the communicator to the 250 ohm resistor. The resistor is required whenever you're doing a bench test, because if you do not have it, the communicator will not be able to receive the protocol because the power supply will eat the signal because it considers it noise or trash. Now that the transmitter is hooked up, I'm going to go ahead and show you how to find the configuration parameters. So you go to configure, manual setup, sensor 1, and here you can find your sensor type, your wire connections, your units, and your dampening. Now we go back, then we go to analog output, PV configuration, and this is where you find your lower and your upper ranges. So now that we found our ranges, which is 60 degrees to 100 degrees, this is the 5-point check. So you can go ahead and pause it. So earlier in the video, we discovered that we're dealing with a thermocouple. So TC, 2 is positive, 3 is negative. And we also discovered that it's a type K, red and yellow kilofellow. So if you look right here, I'm going to go ahead and hook it up. So once again, yellow is positive and red is negative. What I have here is a Fluke 726 multi-driver, which I'm currently using to simulate the thermocouple. So I have it in Fahrenheit and type K. And you always want to make sure that when you insert the forks correctly, you insert them the right way. One fork is bigger than the other. I currently have the driver at 60 degrees Fahrenheit. But if you look at the overview of the transmitter, it's reading 64.4 with an output of 5.8. Now I set the driver at 70 degrees, but the transmitter is reading 74.4 with 9.7 milliamps, which is off spec. Now I'm going at 80 degrees Fahrenheit. Transmitter is reading 84.4 with 13.7 milliamp. Next is 9 degrees. The transmitter is reading 94.4 at 17.7. Now I'm producing 100 degrees Fahrenheit. Transmitter is reading 104.2 with 20.5 milliamps, which is telling me that the transmitter is off spec. And that's how you test a 3144P Rosemont temperature transmitter. I'll go ahead and make a part 2 to show you guys how to calibrate this transmitter and commission it for the system.